Alright, so we're on page 25. I'm still in the process of marking your theory books. I've done about 5, I think. Got a few more to do. I'll get them back to you as soon as they're marked. I'll come find you today at some point. Alright, page 25. In your notes, we're looking at similar triangles.
No, I'm going to steal it. I'm going to steal your pen. I am not Ruben.
So, yesterday we looked at congruent triangles. So congruents mean they are exactly the same shape, exactly the same size. Okay? So, similar is when we have the same shape, but of a different size. So, your application is when you're on a Microsoft Word document and you paste a picture on there and then you click the bottom corner and you make it bigger and smaller. Okay? So, that's an example of similar figures. Typically, your picture is the rectangle format, or the clipping around it, and you drag it out, you're making either a bigger rectangle, or if you drag it in, you're making a smaller rectangle. Okay, so that's what we're talking about, similar figures today, similar triangles specifically today. So, on your notes, congruent triangles, two triangles exactly the same shape and size. So similar triangles are two triangles of exactly the same shape, but can be different size. Alright, there are 3 tests for similar triangles. Right, the first one is triple A. Right, that means all the angles, the matching angles in both triangles are equal. Okay, they are the same. We have the triple S. Now this one is when sides are in the same ratio. Alright, so if you think of the image on your computer and you drag the box out, alright, and you make the, let's say you make the breadth of the box double the size, okay, that means the width of the box will also, you are doubling in size once you drag that bottom corner out. Okay, so the sides are in the same ratio. So you have what's called a scale factor as well. You might have remembered that from junior school. And this is an application of it with the same ratios. The other one we can have is the SAS. So in the congruent triangle, that was the side angle side with the included angle. So it's exactly the same. The angle itself has to be the same.
What was that?
Guys, remember you are on video.
You just sneezed on my shoulder. You did it to me yesterday.
Quit your whinging.
That's right, that's like a camera cut.
So the angle's the same, but the two sides, just like the triple S test, the two sides are in the same ratio, and the included angle is the same. Alright? So included angle are equal, and the sides in same ratio. So two similar triangles can be congruent, two congruent triangles. Two triangles are congruent. Two similar triangles are congruent if the ratio is 1 to 1. Okay, that's the other point. So angles are equal. Okay, so two triangles are similar if the corresponding angles are equal and the corresponding sides are in the same ratio, or one angles are equal and the two sides form that angle are in the same ratio, will be enough to state two triangles are similar. Right, so again you'll be required to write 5-line proof, so we've done that in the congruent triangles yesterday. You'll be doing this very similar thing in your proof here. Right, so we're on page 25 of your notes, so I can't project it right now. Alright, so let's look at some examples. Alright, so very quickly drawn. We have 12 centimetres. You have 8 centimetres, 12 centimetres, and 18 centimetres. A, B, C, D, and E. Okay, so you're asked to show the following pairs of triangles are similar. So we start with what we're stating. So in triangle, so we're going to do the left triangle. Make sure to label it correctly. A, B, C, or any combination of those letters will be fine. And triangle, I'm just going to go alphabetically, C, D, E. Okay. Right. So when it asks you to prove that two things are similar, that means it must be similar somehow. You need to work out why and construct that proof for it. So, good. Alright, so we know that the vertically opposite angles are equal. Okay, so that's assumed knowledge. It's part of what we've covered already. Alright, now we need to detect whether sides are in the same ratio, the adjacent sides. Okay, so let's start with the angle. ACB is equal to angle DCE. Okay, and you must give a reason. Vertically opposite angles are equal. Emily, can you shut the door again, please? Alright, so if we look at the ratio, if we go this side of the left triangle over this side of the right triangle, it's going to be the same ratio as this side of the triangle over that side. Because one can simplify 8 over 12, that simplifies down to 2 over 3. Okay, and 12 over 18 will also simplify down to 2 over 3. Okay. So let's write that. So the ratio of BC, I'm going to write the ratio as a fraction over, C. So BC over CE, okay, which equals 8 over 12. So 8 long and 12 long. And we simplify that fraction. So the rule is whenever you have fractions, they always need to be in simplest form unless told otherwise. That's in any context. Alright, whether you're dealing with algebraic fractions, whether you're dealing with ratios, fractions in problem solving, whatever the case, fractions always in simplest form. Alright, so that was the top sides of both triangles. So now let's go to the bottom. So we've got the ratio AC over CD, which equals 12 centimetres over 18, and then we simplify 12 and 18. Alright. So we have 2 over 3 because they both have the common factor of 6. So what you need to do is identify sides that are in the same ratio when we're proving similar, and then I have broken down both these fractions if they're the same. Therefore, those two sides that form the angles are in the same ratio. Okay, so which is same ratio as BC to CE. Okay, so whenever you see a ratio, like the column there, alright, so basically the left-hand side of the column will go on top of the fraction and the right-hand side of the column will go on the bottom. Okay, so that's how we deal with ratios. Okay, so you're making some sort of comment that the ratios are the same. We've already shown the angles are equal, and that's enough to show those two triangles are similar. Okay, so therefore, triangle, so restating your first line as you've written it already, is similar. So that's 3 vertical line, congruent, like an equal sign. They're the same with the line above or below the equal sign. And similar are 3 vertical lines, which is similar to triangle CDE. Alright, and then we give our test. Alright, so one of those 3. Now let's see what I've done from yesterday. Cool. Right. Right, any questions on that process? Right, so what I've done is I've somehow copied the congruent triangles down there to a couple of those examples and didn't put the similar triangles there. Alright, so on the top right, which should be a C, alright, so we're going to do that one. Alright, so let's have a draw. Right, so we're told that these two are parallel. We've got the vertices P, T, R, Q, and S.
They wrote two P's. But then that would still be B. That one there would be C.
I'll go down before I'll go down the page, not across.
Okay.
Yeah.
But then you go across when you work it out.
Yep, today when Mr. Lee's not predictable. Alright, so you are told PT is 21 centimetres. ST is 9 centimetres.
Okay.
And QR is 15 centimetres. Alright, so we need to find the value of PR, the length of PR, and also the length of TR. Okay, so
When you find TR, you'll find TR.
that will be the way. Right, so before we can do that, we need to actually justify that these two triangles are similar. When we do that, we can then easily work out those values. So, we've got a little triangle at the front, and then we've got the whole triangle of the diagram. So, in triangle PST and triangle PQR. Right, so how am I going to prove that these two triangles are similar?
There's one common angle.
It's a common angle, good. What else?
Parallel lines.
Yep, so what angles can we state are equal with parallel lines?
PTS and PRQ.
Good, so these two angles here. What else? So that angle at the front is common because that forms both triangles. These two are equal because of the corresponding, these are two parallel lines. Okay, and that will also mean these two angles up here are equal. Again, got the F shape. Underneath the arms of the F, the angles are equal. So we're going to use the first one. Matching angles are equal. So, angle at P. Now this is the other way you can notate angles. You would usually use 3 letters. However, I'm not going to state one or the other because I'm not going to favour one triangle in here. So I'm going to call it just that the angle P is common. Okay, because that forms both triangles. So angle P, T, S. So remember, we're starting with the first triangle up here, PST, which is the little one. So when I state the property, I'm stating the little, the triangle from the little property, the property from the little triangle first, and then I'll go to the other one, which equals angle PRQ. And each time you do one of these congruent or similar proof, you need to state a reason. Okay? So when that information is already given to you in the diagram, or you need to write a quick sentence, the corresponding angles on parallel, okay, which are equal. Okay, so the two lines can be vertical, it can be a slant, okay, as long as the two lines looking like they're parallel will be enough for your statement. And angle up the top, so we've got the other corresponding, so PST is equal to angle PQR. And again, because it's the same reason as the previous thing we've done, alright, so I don't have to rewrite that sentence, I can just say as above. Okay? So we've just shown those two triangles are similar because the three angles, matching angles, are the same. So therefore, repeating that top line and the order, so PST is equal to, so similar to triangle PQR. That, and the reason, triple A. Or you can say equal angular. Okay? So if you're really into fishing or something, you'll probably prefer that word.
Are you really into fishing, Robin? No. I hate fishing. I just like catching them.
Alright, so to answer the question, we're asked to find the length of PR and TR. Alright, the first thing we need to do is show that the two triangles are similar. When two triangles are similar, their sides are in the same ratio. Alright, so that means where the angles are formed means that side is similar to this side. This side is similar to the whole length here, and this shorter side here is similar to the whole length there. What I mean by that, that they are in the same ratio. So we need to find the value of PR, which is the overall length. So we write some ratios. So the long side over the matching side of the other triangle. So we've done the big triangle first now because that's my variable. Over the shorter side, PT. Okay, so like the first proof. Right, so this long side over the shorter side will equal one of the other sides of your bigger triangle over the matching side of the shorter triangle. So we've got QR over ST. So I'm writing letters just to help you to follow rather than just looking at numbers. You're looking at properties. So PR over the length of PT, which you were told in the question, is 21. Alright, it's equal to QR. Okay, so it has to be the big triangle first because that's what I've started on top of the fraction. The order needs to be the same, which is 15, and then the side on the shorter one, which is 9. And look at that, we have algebra there. Okay, which is always going to be part of every single topic. Alright, so solving PR is going to be 15 on 9. Alright, and we're going to bring that up to the other side. Okay, so we're dividing by 21 on this side. That means on the other side, I'm going to multiply by 21.
Do it in your head, Robin.
I can't do decimals.
You're not even smart.
I am not able. 35.
35. Did that in my head.
Yeah, totally did that in my head too. Right, 35. Now remember, numbers on its own don't mean anything until you have context to it. You are specifying a length, therefore you need to specify the units. So, PR is found, now TR, so this little length here. So we know the overall length now is 35. We know this length from here to here is 21. So hopefully everyone can see it's just a simple subtraction to solve for the last little bit.
Yeah.
Alright, so TR is going to be 35 minus 21 No one should need to go on the calculator to do this.
It's actually 15. Oh, hang on. I've got to use a calculator.
No.
I knew it was 14.
Chest now.
Okay, so did we do similar triangles last year? Did you find length of sides using similar triangles?
No, really, just said they were similar.
Okay, is there anyone here that is not following the process? So you're all following somewhat what to do?
Yeah, somewhat.
Yep. Well, I don't expect you to know these things straight away. Okay, that's why you have homework. Alright, next thing. Alright, so another property of this. Alright, so if you have more than a pair of parallel lines, so you have 3, for example, and you have more than one transversal. Okay,
It looks like a fan.
So, as well as similar triangles, we can do this sort of ratio stuff here with some 3 or more parallel lines. Okay, so the section of the transversal will be made in the same ratio. Okay. So, that means that will be in the ratio of that, and that will also be in the ratio of that. Alright, let's have a look at an example with numbers. Because we all like numbers, don't we? Alright, so you have these 3 parallel.
What? That was meant to draw what?
Wait, were we not meant to draw that top one?
No, it's on our...
It was just what's in the notes, so I'll try and explain it.
Whoopsies.
Alright. So I'm not going to write out the whole question. We do know these are parallel. Okay. You are told these 2 are equal. You are told this is 28 millimeters. So we've got A, B, C, D, E, F. Alright. So, you're told that. Then the question is states that AB, which is equal to BC, so that's equal to that. DE, which is 28. And GI, so the oval length from here to here is 58. So GI is equal to 58 millimeters. Alright, so we need to find EF. We also need to find GH.
No.
Right. So what this is saying up here, is we're going to equal ratios on when we draw transversals through some parallel line. Okay, but what I'm going to do here is we're going to match sides using our similar ratio. So the first thing we need to find is the length EF. Alright, so I'm telling you it is going to be 28. Alright, because these 2 are equal. Alright, because of these 2 are equal, these two will also be equal, and that will also be equal. Alright? Only because you are told specifically that they are equal.
Wait, isn't GI 58?
Okay?
That's due
Yeah,
to
that's-
I.
GI.
That's all of it.
That's the
So,
entire
Yeah,
so
but-
28
Yeah,
plus
it's similar.
28 plus 28 is 56.
Alright, so let's write a ratio. So you're going to work all these questions with a ratio. So we're finding EF. You need to find a matching side. Okay, and then use information on the diagram to set the rest of it. So, because these are equal, alright, I'm just going to call it 1 unit. Okay, because we don't know how long they are. So if I go this side over the side above it, right, which I'm going to call 1. The reason why I'm calling it 1, because these two are the same length here and here. Okay, so I'm specifying any number I want, or any variable I want. Alright, and I know how long it is from here to here between these two parallel lines, and I can use what I've stated for here to tell me how long this side is here. So 28, so did that over that, which must equal that over that. Alright, so it'll be 28 over 1. Okay, so EF is going to be 28.
Yeah, okay.
Yes, please.
Right, so GH now. So again, we want this here to here. So I'm going to write that as the top of my fraction on the left. If you do that, that'll be less working you need to do to rearrange fractions, etc., etc. Okay, so we don't want to make the work more difficult, we want to make it simple. So, GH, so this little bit here, over the overall length from here to here. Alright, so which is 58. So I've gone this little one to the overall big one. You've got to keep that same thing in the another one. Okay? So, if I've done this over the overall, I'm going to go the line above it. So I'm going to go this little one here, which is 28, over the overall distance. Okay? Which is 2 times 28. Okay? Because we know the value of that there. Right, and the reason why I wrote 2 times 28, because I can nice and easily cancel. Simplify fractions as you go. Alright, so I need GH by itself. Alright, so I need to multiply by 58 on the other side. So it'll be 58 on 2. So in other words, half of 58. Which is...
You're right the first time, mate. Shut up, mate.
Alright, so that works because they're equal, okay? So you can go and state the values of these because you know the ratio are equal here and here. However, that won't be for all questions. Alright, let's go to the next one.
It looks nothing like it else. Amanda, that looks nothing like it does. Amanda, that's not a duck.
Those are some lovely parallel lines.
It's not
Right.
a duck, Amanda. You're a retard. That's not a duck. That's a 2 with a sag nappy.
Right.
How did you
I don't know, but
Alright, so here you're not told anything's equal. Alright, so this is where you need to use your ratios work. Now, there is more than one way you can get the correct answer here. Alright, as long as you are consistent with what you are setting. Alright, so I'm going to do it both ways. So we need to find the variable x. Alright, so I'm keeping that in the top left because that'll make it simple to solve. So, there's a couple ways you can do this. This side over that side is equal to the same ratio because of the parallel line of this side over that side. Okay, so x over 8, which equals 9 over 5. Or, so again, I'm going to leave the top left on the fraction this side, and I'm going to go that over that equals that over that. Alright, as long as you are consistent, it will work. X over 9 is equal to 8 over 5. Now, if you really want to be adventurous, and you probably wouldn't do this, right, you can also state this over the overall length is going to be equal to this little bit here by the overall length. But we're not going to do that because you're going to have variable at both top and bottom. You're going to create more work for yourself. So, x equals 9 on 5, and then we're going to multiply by 8. And the same thing here, x is going to be 8 on 5 times 9. So on top of your fractions, you have 9 times 8, 72, and the top of this fraction, 8 times 9, also 72. Alright, so it doesn't matter how you do it, as long as you are consistent with the sides you are matching. So you cannot do this over this is equal to this over this, okay, because it's not matching. Right, you have to follow the same path with a different line.
72 over 5.
14.
14.4.
Okay, so you can leave it as improper, or you can leave the decimal because it has not specified what unit to answer your question. And don't forget your units, please. How much time do we have? 35.
Planning for the future.
What did we do?
Planning for retirement.
I feel like a wide plan.
Alright, are there any questions?
Nope. Easy as.
Alright, so part of your homework is to also read on page 27 on quadrilateral. Classifying the different types of quadrilaterals, which is a four-sided polygon. Okay, so there's quite a detailed list of the quadrilaterals and also the properties of those quadrilaterals, okay? So I'm going to leave it to you to have a look at that, and I'll refer to it when I'm answering questions. So, on page 29, I'm going to keep going. I'm going to keep going. No one has their books, so I might as well do some more theory. So, that's that section done. Right. So, the angle sum of the quad. On page 29. Right. Thank you. Remember, we have a video recording. Thank you. So, did anyone know the angle sum of any quadrilateral?
360.
Every single quadrilateral is 360. Alright, so we've got proof 4.4. Why is it every single quadrilateral the angle sum is always 360?
If you were to
Because
unfold
you
it,
can put it into two triangles.
Very good.
right.
Alright, so let's draw any general quadrilateral. Whatever.
That's good thinking.
Okay, diagonals are what's called inside opposite corners. Not opposite necessarily, but from corner to corner that doesn't form the perimeter. They are called diagonals. Okay, so gone through the proof, the angle sum of a triangle is 180 degrees. Alright, so if you draw any quadrilateral and you put the one of the diagonal, that quadrilateral is made up of two triangles. Okay, so if the angle sum of the triangle is 180, and we also have the angle sum of the second triangle as 180, we add those two together because that quad is made up of two triangles. We have the angle sum of 360. So in terms of writing out a proof, let's go A, B, C, D. So diagonal B, D is produced.
What was he go today? So hyper.
No, stop that. No.
Right, so diagonal BD is produced, which implies that A, B, D and B, C, D are triangle. Okay, three-sided polygon. And we know the angle sum of any triangle is 180 degrees. Alright, so 2 times 180, which is 360 degrees. Alright, so therefore the angle sum of any quadrilateral is going to be 360 degrees. Alright, so part of your homework for this section will be reading through your specific types of quadrilaterals because you need to know the properties of all of your main types of quadrilaterals so that when you do these sort of questions you'll be able to answer them.
That wasn't funny. I don't.
Amanda, if you need to step outside for a moment, can you do that please? Alright, let's start the examples. A. So we have a Alright, so what type of quadrilateral do I have there?
Yeah, what's he called?
Alright, so when the opposite sides of a quadrilateral are parallel, you have a parallelogram. Now, within a parallelogram, you can have very specific types of parallelograms. What do we call those?
Rhombus.
Rhombus, what else?
According to the number,
It's also a square,
A diamond.
rectangle. A square.
A square. What else?
Rectangle.
Rectangle.
Those are genius. You say diamond.
Yep.
Okay, so
Diamond.
It's all a shape. It's just a square.
a
Play school so
square, a rectangle, a parallelogram is a type of parallelogram. Okay, can be either parallelogram. However, a parallelogram is not necessarily a square, a triangle, a square, a rectangle, or a rhombus. Okay, so also when you have the opposite side parallel, alright, means the opposite angle are equal. Okay, that is one of the properties of your parallelograms. Alright, and that's what you'll read in the note. So, we can quickly state the value for B. The B is, B degrees is 115.
Reason.
Okay, and a reason, the opposite angles of the parallelogram are equal. And how do I get the value for A?
had it.
Like 60 take away 130 divided by 2. 230.
230 divided by 2.
I said
You said 130.
130 off 360 divided by 2.
What's the more simple way of doing it?
230.
Where did 130 come from?
230.
Wait.
Wait. Oh, wow. Okay, don't worry.
What's the more simple way of doing it?
Taking 115 away from 180
Why?
because they're going to be 180 because of the triangle thing.
What? Because they're going to be
Oh, no, co-interior angle.
Co-interior angles. So 180, take away 115, which would be 65. Alright, co-interior. On parallel line, not equal, they are supplementary. Okay, and that's what I'm saying. We don't need to make this more complicated. We don't need to find double 115, take it away from 360 and then halve it again to get the angle. Okay, it works. But often if you're going to do that much work for it, there can be a more straightforward solution. Alright, last one for today. Alright, B.
I didn't have a coffee. I made a comment.
Right.
Oh, you don't
Spice
drink
coffee
coffee is
black?
white. Like, not white, it's yellow.
It tastes so bad.
It's yummy.
How could you forget the
There you
milk?
go.
No, there was no milk. I ran out of milk this morning. Your parents drank it all.
Can you find a cow?
Yeah, put your coffee cup underneath the cow.
Steal the cow's milk.
I was wondering why they went to McDonald's so early in the morning because they wanted to get coffee.
Alright. So we have what type of quadrilateral?
Parallelogram.
Another parallelogram.
I.e. rhombus.
No, it's a diamond.
Wow, it's a square, obviously.
Obviously, it's not a rectangle.
Right, based on the evidence there, what can you definitely say it is? What type of quad?
Parallelogram.
Parallelogram, because you know only that the opposite sides are parallel. Okay? You're not told anything about the angle. Until you know more info about the angles, you can state only it's a parallelogram. So, in a parallelogram, opposite sides are parallel. Opposite sides are also equal in length. Okay? Opposite angles are equal. And what's the remaining property that I need on a parallelogram so that I can answer the question? Find the values of x and y.
I have no idea.
What do you think?
Well, they're the same
You
length.
can do the
No,
ratio.
3y minus 1 will equal 5.
Diagonals bisect each other. Alright, that means that side is equal to that side. And that side is equal to that.
X equals 4.
Bisect mean cuts in half. So when you draw the diagonals in a parallelogram, a rhombus, a rectangle, a square, they will bisect each other at 90. They will bisect each other. Only with a rhombus, they'll bisect and a square. They'll bisect 90 degrees. Okay.
Well, that was easy.
All right, very quickly. So we have x equals 4.
Reason being,
Alright, and we also have 3y take away 1, which is 5. So 3y is 6, y equals 2. So x is 4. You've already told the units on your diagram, so you don't need to write it again. And the reason, diagonal of parallelogram.
Oh, yeah, we have a dental thing. We have a dental thing.
We got eight now. We got
Yay!
We'll do it next week.
that's next. The thing's next week.
Oh, is it? We do have physics then.
Yeah, let's go.
What do we have next week then?
Alright,
We have business.
Come on, you think.
Where's my lid?
so I'll come find you at some point today and I'll give you your theory books back. I've got the next couple of periods off. I'll be marking, checking, and I'll come find you at some point today.
Yes.
Where's my lid?
I have the lid. Where's the lid? Come on.
Because I dropped it.